Now, one of the things that students find the hardest in this unit is making ray diagrams. And the reason is it's just because you have to be really tedious. You need a protractor or a ruler. I prefer a protractor just because it's a little smaller and you're only using it to draw a straight line, so it's a little easier. There are two lines that you want to draw when you're doing a ray diagram. The first one, you're just going to draw a straight line till you get to your lens. Okay, and then you're going to draw this line and have it go through the focal point on the other side. Okay. The next thing you want to do is you're going to draw one of these lines, but you're going to have it go through this focal point and you're going to have it stop at the middle of the lens. Okay. And then you're going to draw another horizontal line like this. And then wherever these two meet is where your little, where your image is at. Okay. And so that's your image. Okay, so this is your image. This is your object. Whatever you start with is your object. This is considered the focal point. Okay. This distance right here, this blue line, is considered the object distance. You might see this as DO in your formulas. The focal point you'll see is an F in your formulas. The height of your object see if you can see this yellow. However high your object is, that's known as your object height. And it's HO. Okay, and then you have some other things. You have this right here, the distance from the center of the lens to your image is going to be the image distance. You'll call that DI. The height of your image, how tall it is going to be your image height. Now, if your image is upside down, it's going to be negative. Or right side up, it's going to be positive. And this is important for when you put this in your formulas. You need to have your HI negative if it's upside down like this. Otherwise, it's not going to work. Your math is going to come out weird. Okay? Sometimes we'll ask you to measure this with a ruler, and sometimes we'll actually ask you to calculate. And things you should know how to calculate from a ray diagram is your HI, F, DI, HO, I already have HI, DO, and your magnification. Okay, and there's a video of one called magnification and one called lens math, and it shows you how to calculate all of these things. So I would look to that for calculations. Now let's draw some more ray diagrams just to make sure we know what we're doing. So this ray diagram, students always get confused in this one. So you can draw this line right here, and then you can draw the one that goes through the focal point on this side. But then when we go to draw our other line, we can't make it go through this focal point because our image is actually on the focal point. So when you have something like this, you're going to have no image. Okay, on our lens lab, you're going to put your object at the focal point, and every time students say, "Oh, my image was this far away," and I'm like, that's impossible because there is no image when you're at the focal point. So just keep that in mind. If you write that there is an image at that point on your lab or on your test or something like that, you will definitely get points taken off because it's impossible for there to be an image. Okay, so when your object is at the focal point, you will have no. So now we're going to try one where the object is closer than the focal point. So I'm going to draw a line up like this because I'm going to need it in a second. The first thing I'm going to do is draw my horizontal green line, like always, and I'm going to draw a line that goes through the focal point and also hits this green line. Now, the light's actually going off to the right, so I'm going to make this part dotted because it's not really what's going on, but I need it in order to find my image. So then I need to draw another line, and it has to go through the focal point and the top of the object. And then it's going to go horizontal off to the right and horizontal off to the left. And the part going off to the left is actually going to be dotted because, again, that's not really where the light is going. I just need it to find my image. Now, even though I don't, I know these lines are going to meet somewhere off the page, but I'm not actually going to be able to find my image. But I do know a couple of things about my image without even seeing it. I know that it's going to have a positive height. I know that the distance is going to be negative because it's on the same side as the object. I know that it's going to be bigger than the object. And because these two rays are diverging, I know that it's going to be virtual. And if I actually wanted to calculate the height and the distance, I could because I have the focal length and I have the height of my object and the distance of my object. Now let's try a concave lens. In this one, it works just a little differently. We're going to have our first horizontal line, like we always do. And it's going to hit the middle of the lens. And then it's going to go through the focal point on that side. Okay, and since the light's really going off up to the right, I'm going to make the part on the left a dotted line. Then the next thing we're going to do is we're going to draw a diagonal line that goes through the focal point on the other side. And then where it hits the center of the lens, I'm going to make a horizontal line off from that. Okay, and so I'm going to dot this part because it's not really where it's going. I just had to do that to see, make sure I did it through the focal point like I was supposed to. And then we can find our image, and he's going to be right here. We know a few things about our image. We know that his distance is negative because he's on the same side as the object. We know his height is positive because he's going up. We know that he's smaller than the object because these two rays are diverging. We also know that he's virtual. And if you actually wanted to calculate his height and his distance and all of that, you know the object distance and the object height, so you could do that. And then all you have to do is just make sure you make the focal point negative. Otherwise, you're going to get answers for a convex lens instead of a concave. So just keep that in mind. Now let's try a concave lens where the object is closer than the focal point. So I'm going to draw my horizontal line again from the top of the object. I'm going to draw the diagonal line, and it goes through the focal point on the same side as the object. And so I'm going to make this part dotted because it's not really where the light is going. Then I'm going to make another line that goes through the focal point on the other side. And then where it hits the center of the lens, I'm going to draw a horizontal line. I'm going to draw this one dotted because we really only need it just to show us, make sure we have the angle right. And then we can find our image and where these two intersect. And we know a few things about him. We know his distance is negative because he's on the same side as the object. We know that his height is positive because he's not upside down. We know that he's smaller than the object, and because these rays are diverging, we know that this is going to be a virtual image. So what I would recommend that you do is I'd recommend that you do all the practice ray diagram problems in your packet, and then I would make sure that you do those again right before the test, and that'll just make sure that you are fresh and you know how to do them. Drawing ray diagrams is not like a bike. If you don't do them for a few days or a couple weeks, you'll forget. So make sure that you practice them again right before the test.